All right. Remember how we do this?
That's not it.
I go first, right?
Yeah.
I'm Martin Wallace.
I'm Darren McCarthy.
And I'm Dan Fury, and this is The Fundamentals.
What are we talking about?
Well, this time, it's 3D printing.
It's 3D printing.
And this is something that I wanted to know about because it is astounding to me, the idea of it. And I don't still necessarily understand how it works or what it really is.
Unfortunately, I don't think at the end of this you're really going to either. It's
Damn it.
There's a bit of like technical engineering and way more, like if you go back and listen to our plastic episode, a lot of that comes up. A lot of like the real nitty gritty is in polymer choice and...
Yep.
But you're going to know a lot more. Yeah, you're going to know a lot more than you did. So we're talking about additive manufacturing.
Yep.
That is 3D printing. Layer by layer additive manufacturing. So 3D printing is a variety of different processes. The most basic form of it is going to be a nozzle, adding whatever the polymer or whatever type of material you're using to make the product, layer by layer, just adding these parts to it based on a computer model, and the computer model is sending information to this printer that is working in a 3D space to create an object layer by layer. And there are some that do subtractive manufacturing, which is where you put in a whole block and then it chips away at it like you would a statue.
Right.
But that isn't 3D printing. That's a different process. And you can utilize both of them at the same time now, which is one of the ways in which 3D printing is growing exponentially.
Because you can buy a 3D printer.
Absolutely.
Mm-hmm.
You can buy a 3D printer that prints 3D printers. So you could buy a 3D printer that makes its own upgrades. I'm looking
at a list of 3D printers right now. They range from about $1,800 to $3,000.
Oh,
that's your desktop printer.
That's desktop.
That's crazy.
So the company that my dad used to work for.
Yeah. What's up, Dan McCarthy? We were going to try to have him on this episode.
Yeah, businessman Dan. They made printers that they're like $40,000 for a unit. I mean, but they have a nozzle that's shooting wax that it's like the order of magnitude is like 7 atoms. It's
whoa.
It's ridiculous. It's tiny, and they're selling these units for jewelry makers. So instead of taking a diamond that has some market value and then, or like the ring itself, like the setting, they just print it and say, "Oh, does it look good? Yeah, looks pretty good. Okay, let's get a diamond in here and actually make that." But then you have these desktop versions, and you can build your own for even cheaper. That's like that's like one you would buy,
right?
Like
Retail.
A whole unit.
An example of usage that I heard, which was interesting to me, was a guy printed a new door for his remote. Often you lose these kinds of things.
Oh, that's interesting.
And he just made a new one.
Yeah, there's a lot.
That's crazy.
There's a lot for like kitchen appliances.
Yeah.
Or so
you download models essentially. Like this is the program to make this thing.
Think about this. If you know how to download an image, you could download a 3D model. Like it's just the file. The way it's written it's a file written in 3 dimensions.
Right.
It's called CAD, computer aided design.
Yeah,
computer aided design. It's it looks like 3D graphics software of any other type that you would use for game modeling or for movies or.
The company that I work for right now, this is essentially what all of the parts we make is written in.
Okay.
So CNC machines, we're doing subtractive. So we're taking away the material to make parts.
Making a thing out of a slab.
Yeah, so
of
you're like...
Now, of course, this is really good for production.
Yeah.
But it's not really good economically or environmentally.
Yep.
you have more product or you have more material originally and you remove it to make product,
waste.
You can make a lot of product really fast and make a lot of money, but you're wasting
a ton,
all kinds of material. If you could do it from the inside out.
Some of the things we make really high quality parts. But you think about, all right, so we are taking a bar that's, say, like 2 3/4 in diameter, and then probably about, say, like 4 or 5 inches long. It's a pretty substantial piece of like aluminum, which is expensive. I mean, you're talking several dollars per inch. It's an expensive block of material. Instead of like adding to that, you're taking away. I'm just kind of ballparking here. Probably about 3/4 of the material to make the part.
I'd say you've got to carve 70% of a block out to make
just
a
to make
tube
the part.
Or whatever it is that you're making.
You're boring a hole through it, and then you're carving on the outside of it.
Yeah,
and there's no good way, at least for your company, I'm sure, to recycle that material in house.
We do recycle, but we do have to send it
to another
offsite.
plant to take care of all this aluminum, put it back together, or whatever the substance is.
So we get some money back, and it's not just like thrown away into a landfill. But if you look like the premium dollar, because we also do buy the highest grade materials. So like the aluminum we buy is like it is literally the same stuff that that NASA would use. It's or Boeing. Boeing is. It's a local company for us here. So the reason that we're able to even get that high quality aluminum is because the mills that make that aluminum are already shipping to this part of the country.
Oh, that's great.
To Boeing. If they weren't, if like we were just in Alaska, they would say, the value of this material and for us to ship it, like it wouldn't be worth it. So we're taking that material and we're taking 70% of it and recycling
shaving it off.
Yeah, shaving it off.
3D printing is a name that kind of it's the cheapest way to call this process. And it's going to stick because it is the easiest, most descriptive way to explain it, but it's an umbrella term. Certainly, and it comes from a process called stereolithography. That was the original 3D printing idea, and it was invented by a guy named Chuck Hull, in 1984. Been around a long time. Now, there's a little bit of controversy because there's a Japanese inventor of a similar idea and some French inventors of a similar idea.
Anytime there's a technology like this, there's always a few people who lay claim to it.
But the most productive use of it came from Chuck Hull.
Okay.
American patent. He mixed ideas of the other two to create a product that works very well. Way. Yeah. The stereolithography is a process in which layers are added with these polymers that get hardened by ultraviolet light, which you might remember from our plastic episode. Polymers can be given properties like that, where they can either retain their hardness or be melted back down and broken and all kinds of different properties. But these particular polymers are liquid almost in form, very, very soft. And then when blasted with this particular spectrum of light, harden up. And so what happens in stereolithography is a nozzle, very, very much like a regular printing jet head, will lay a tiny little layer of it on top of something, that layer by layer, and then be blasted with light. It'll harden, and then it'll lay another one down. So forever, this was very, very slow.
Yeah.
Very expensive.
I mean, regular printers in 1980, mid-80s were
think about
incredibly slow.
How long did it take to print a page? Now try to print a car.
This is like
going to take, days and days. So the technology is there, but everybody in the business world is looking at this going, who cares? Right? Like, it's amazing that you can do that for sure, but it's like DNA sequencing or genome sequencing. Until that is instantaneous, it provides no benefits. It's cool.
Great idea.
Yeah, and it's great and has, like if we can look at somebody's whole DNA sequence, that's amazing. But until we can look at everybody's and have some kind of computer that analyzes it across the whole spectrum of things, which is coming, but that's not this episode. It doesn't really do anybody any good if it's so slow. And so that's kind of the fate of 3D printing or stereolithography for 15 to 20 years. We've had this technology since before I was born.
Right.
Why is it a big deal now is kind of the fundamental question. And it is this exponential growth of speed and size, both in large scale and in micro formats. There are 3D printers now that are big enough to produce airplane parts and cars.
It's crazy.
Yeah, you can build a whole airplane with one of these, right? But there's also 3D printers that are so tiny, like sevenths of a micrometer, that can produce computer chips. And roughly using the same sort of process, there's several different processes. And what that is that's extrusion is the term for it. It gets extruded. Some kind of material gets pushed through a nozzle, extruded into a layer by layer format, and then is light polymerized. Is what they call that when it hardens by UV light. There's also powder bed and laminated, but you don't see either of those quite as much. Powder bed's more for metal. What they do there is there's a layer of powder that then gets etched out and then blown away, and what was etched is what's left over. And so you can do like really precise things in a powder, and it's kind of like polymerization in the same way with the light. You sort of hit this tiny part of a powder with a laser, and that part hardens, and then the rest of it is blown out, and what you have left is this really precise, tiny little piece. But that's kind of part of the exponential growth of it, is all of these things, including the subtractive manufacturing that you were mentioning. If you can do all of these at once and fast, you can build an incredibly complex thing effortlessly, simply by telling the computer to do it. Here you need to shave off this thing that I just squeezed out of a tube and hardened with light, and you just need to shave it off. And if you can do all that in this 3D realm instantaneously without any effort, you can create incredibly complex little pieces of product. And we're getting really close to an age in which you can create these kinds of things in your own house for very, very cheap.
So I am thinking of this, I'm trying to think of this on the consumer level. How big is a home use 3D printer?
They're really small. Like so,
same size as a jet printer.
No, even smaller. Think
they
about.
They can make them smaller. Yeah.
Think about like a coffee maker.
Think of like a hollow box.
Yeah.
So whatever you're printing can only be so big.
That is the problem.
But it's also how. All right. So how big of a machine do you want in your house?
Well, it depends on what I would like to make with it.
Okay, so if you're gonna say you wanted like a car,
right?
Do you need a machine big enough to print a car in your house?
No.
How many times have you bought shoes and watch once a year? All right, and then how about like kitchen utensils anytime you moved, or you need stuff like that size.
Right.
Have you ever been like, oh my God, I don't have a measuring cup right now? Or like
yes.
I just need a measuring cup. You can just download the measuring cup from an Etsy-like website design that you like, and it'll just ploop.
Can you use different types of material?
Yes.
In the same? Do you have to get like a cartridge of this thing?
No. So it would be like for the like plastic polymer ones. It's kind of like a coil of think of like a ball of yarn. So instead of like having like any sort of like ink, it's like a ball of yarn that's just being melted down into liquid and then extruded out, and then it's hardened. Or it's like a resin. There's some printers that it's just like a resin bath. So it's like liquid.
I imagine like you would keep hot water for like one of those instant coffee machines.
Yeah, it's just like it's like a Keurig machine.
Okay,
sitting on your
pushing
kitchen
liquid,
counter.
but
does one machine? Is one machine capable of using different materials, or is it made to use one?
Yes, but what you're describing, those machines are big and expensive right now.
You couldn't just go buy one for like plastic and metal.
Right.
Not going to happen.
So just think about the logistics. Think about the logistics of keeping a moldable, pliable metal in your home.
Yeah.
Right now, it's not very possible, But very soon, that'll just be the norm.
But right now, you could be in your kitchen looking at a recipe, and it says you need a quarter of a cup of, or a tablespoon of lemon juice, and you have a lemon, and you don't have any sort of like citrus juicer, you could print within minutes a tool that has like, you know, like this weird like ridges. It's like it's just designed to go into like half a lemon, and then like you just grind away all the juice. You could print that out of antimicrobial plastic in your kitchen.
Guys.
And the best would be a day when you can then take that product that you just made and put it back in line to be turned into another product.
So you need it for this one recipe. You don't need it for 6 months, but
just need it right now.
I'm going to need a measuring cup.
Need a measuring cup
tomorrow, so I'll just put my plastic back into the
for the same recipe.
Vat. Yeah,
that's great.
That's a pipe dream that people are working on.
I'm sure.
Another one is printing food.
Yeah.
They're working on 3D printing food.
It's not as far-fetched as it sounds. Think about confectionery chocolate. Like, think about really high-end, like restaurant quality desserts. Very
specific types of.
It's design, not the food that they're working on. They're working on making little truffles in these really complex, cool shapes.
So they need like chocolate as the medium instead of plastic or.
It works in exactly the same way as the extrusion process. You just have chocolate or whatever the ingredients are, and it prints layer by layer.
They're working on this for crackers, pasta, pizza. NASA's involved.
And think about what it would do to the kitchen if you could just have a list of your basic ingredients that were part of this machine that said, look, I want to make spaghetti. So it's going to put all of the wheat into a thing that makes noodles for you, and it'll just extrude them out.
You have like fresh pasta without having to have someone who actually knows how to make pasta.
And one of the ideas was to make pizza that way, because anything that's like layered, they can do.
Yeah.
Because you can do the base of it and then add the sauce on top and then add layer by layer. You can just squirt meat out of the tube into the shape of the pepperoni.
So gross.
And there you have a slice of pizza. And you know, they're not going to, it's not going to cook it. You have to cook it. Although it could, because there's some heat elements involved. But I only read about that as a theoretical possibility. I really only looked into the sugary treats.
Yeah.
Clearly. Which are cool because there's like incredible designs. And what you can do is you can order one for your restaurant.
Yeah.
Have a 3D printer in your restaurant. You can have
shooting out
made to order designed truffles.
Or you can like pre-order. You can just choose a design that you want. They'll shoot it out, put somebody's face on it.
Think about that. Think about the amount of time it would take for someone to train to the level to make this extremely intricate anything, really. But like, think about like a
well,
food.
You could do that, but this would make it the same way every time.
Exactly.
Every single time.
And you have like a handful of people on Earth who can make
by hand
truly intricate, fascinating pieces of art in chocolate.
Right.
And there are people that do that. Or you could have a machine and all you have to do is be a graphic designer. And it doesn't matter what the medium is, it'll make it.
Yeah.
And that's the bigger point, is that we are coming close to an age in which no matter what the medium is, all you have to do is be able to design it.
Yeah.
And it'll be made for you.
Put it in the computer.
Because you were talking about, okay, how many times do you buy a car versus how many times you buy a watch or
small items,
cufflinks you might need, or a measuring cup, any of these like inconsequential, tiny little pieces that you could make at home. But think about what would happen if, say, you don't have a 3D printer at home that can build a car, but car manufacturers do. Think about how much cheaper cars will be all around if they're just printed. You don't need anybody to work on it.
And replacement parts.
Mm-hmm.
What if you can print a replacement part
you
for your
could.
car.
I mean,
Instantaneous.
However, and the printer size, that's the only defining thing. They already have printers now that are 3 meters cubed.
Pretty big.
You and I, it's the size of this room.
Okay. So you can pretty much
maybe
do
a little bit,
a little bit smaller, I think, but still
square this room.
Mm-hmm.
So something that size you could print today, and that's this is realistically the infancy of this technology.
Right. It's only going to get more complicated.
Now here's something else. Okay, so if you think about recycling, all right. So you've mentioned measuring cups.
Mm-hmm.
At home, I have a measuring cup. The handle broke off.
Yeah.
We still use this measuring cup. If we had a 3D printer that we could just throw that plastic handle and cup back in and print a new one, I'm not going to throw this measuring cup away because it still measures one cup. It's just that I have to get my hand into whatever, I'm measuring. If I had the option, though, to not waste any of it and just print one with a GD handle.
Yeah, just reconstruct it. Can you 3D print, and I'm sure you could, a gun?
Yep.
It's actually highly controversial, but a man has already done it.
Yeah, of
and
course.
They blocked his design, which was publicly available.
Yeah, so in 2012, the US-based group Defense Distributed disclosed plans to design a working plastic gun that could be downloaded and reproduced by anyone with a 3D printer. So they have designed a 3D printable AR-15 rifle lower receiver that would fire around 650 rounds before failure.
What?
And a 30-round M16 magazine, which is... So essentially what they're saying is...
if you already had the 3D printer, it would cost you the plastic.
It would cost you the plastic to print a gun. The AR-15 has multiple receivers, both an upper and lower receiver, but the legally controlled part is the one that is serialized, the lower, in the AR-15's case. Yeah. You can print a gun.
If you can print anything, somebody's going to want to print a gun.
Again, that
was one of the first truly landmark home printed things, for sure.
Yeah.
No doubt.
Again, though,
all this other stuff is for
in
fun.
the infancy of the technology.
Mm-hmm. What we're looking at here is a pretty standard case of early adoption. You can print a lot of this stuff at home. You can spend some, now not nearly as much, but still pretty consequential, $2,000 to $3,000 to have a hobby at home.
Yeah.
But in the future, you're looking at a true change in the way that we live across all measures of it. Like the way that the internet changed our ability to communicate, you're looking at a change in production. And there's a guy named Jeremy Rifkin, who is a pretty well-known futurologist as well as an economic and social theorist, who it turns out has been pretty much right on the future for like the past 30 years. He's like made predictions and been like within 2 and 3 years of those, because he's not a sci-fi writer. He's like he's just pretty brilliant. You should definitely look into some of his predictions. But he's calling for this third wave of the Industrial Revolution with 3D printing. In the way that, like with the internet, you saw a technology that had sort of limitless bounds and was really, really impressive, but you couldn't quite grasp just how much it would change everything. In the way, like, for example, if we did not have the internet right now, how little we would be able to get done compared to how much we get done on a daily basis and don't even consider it.
Yeah.
How much news, how much communication, how much research, even without trying. There's so many times that I just reach for my phone and look up something.
Yeah.
Totally without even considering how difficult that would be if I didn't have access to it. Like I have an app on my phone that is the US Constitution written out, article by article, with notes of constitutional lawyers explaining those articles to me.
Oh, wow.
Just for fun. Right? It's just for fun.
Yeah.
In order to do that prior to the internet, I would have had to buy a book. And that's not really that difficult to do, but I would have had to spend money and interest and go find it.
Now we can probably just 3D print a new phone, piece by piece.
Pretty soon. Yeah. In the same way that the internet was able to influence everybody on a level that was totally unimaginable, Jeremy Rifkin is predicting that 3D printing will do the same.
Mm-hmm.
It is these little things like printing a measuring cup at home. How stupid does that sound? That's not a big deal. If you were to come to me with that as an investment opportunity, I'd say, like, that's great. Who really cares about that? But think about how much that's going to impact the environment when people don't have to go to a store.
All right. So yeah, it's 9:00 at night. It's a family member's birthday party the next day, and you don't have a measuring cup and you're trying to make a cake.
That's a measuring cup.
Well, it's just such a stupid thing. Like,
how much would it be worth to you if the 3D model of a measuring cup cost 49 cents?
Right.
Or you could wait until the morning, get in your car, go to the store and spend $9.99. I mean, I don't know.
Here's the real important thing. What's going to happen to the stores?
Yeah.
Good question. See,
they don't have to sell anything anymore.
This is what just came to my mind while you guys were talking. And I did a quick search and it's already been done, but obviously in a crude way. But 3D printing records.
Mm-hmm.
Mm-hmm.
Taking vinyl as plastic.
Yeah. Taking a vinyl compound and printing a new record on it. So you download the album.
You download a physical copy of a record. That's crazy. I never thought about that.
Well, you would download essentially a digital copy of it, but then print that
into a physical
record.
And have vinyl.
Because it's just etching, right? And they could just...
So you could have like...
That's cool.
Quote-unquote original...
You could make your own
record of the Beatles' White Album or something. Like something like pretty iconic that...
Would be, well, see, there would be copyright issues and stuff. But if you pay for the download,
But they could sell that, though, as the collector's edition of whatever.
Right.
You know.
And obviously, everyone would be a little bit different, given that, well, you could make it different and that you could use different colors, choose whatever color that you want for this compound. But again, you could make your own records pretty easily.
I suppose we should jump back to basics here for just a minute because it explains a lot of what the future ultimately will look like. The main purpose of additive manufacturing up to this new sort of era of industrial revolution that we're perhaps on the edge of, it has been entirely about prototyping.
Mm-hmm.
That's its major application. If you can make a plastic prototype cheaply of a product that you're about to mass produce, you can look at all of its flaws and all of its intricate workings before you make it a reality. But what we're about to start doing is to be able to make full products in the same method, cheaply, quickly, and without any human effort other than graphic design.
Mm-hmm.
And just think about what that's going to do to production.
Right. We have a prototype department.
Mm-hmm.
We've got 3 machinists in the prototype department, and to prototype a part with labor and materials and parts, I don't really know because it's not my department, but I think just from like labor, I mean, these guys are really talented.
Yeah.
They're artists. And it's like, I don't know how much they're getting paid, but they're worth at least $50 an hour, $100 an hour, somewhere in that range. Somewhere between $50 to $100 an hour is how much it costs to like these guys to be doing stuff with the parts, the wear and tear machines.
It's got to be incredibly intricate to write the code that makes the thing on a 3D printer.
These guys are using lathes that are 40 years old. I mean, they're like manually making these parts.
Yeah.
So it's the difference between like a painter and a printer.
Right.
You know?
And to answer your question, it's really not. There's not a lot of code. The code's already been established in making the process of this program. What you're looking at now is essentially just graphic design, which you can teach yourself. I mean, you'll not be great at it, but you could teach yourself enough to, again, make a measuring cup.
Yep.
Easily. You won't
design your
have to
own
buy
measuring
it from
cup.
somebody. You could buy somebody's great design that you like
Well, yeah, but
of a thing, but you could make that object easily.
the printer needs to know depths and
Yeah, but the language for that
uh-huh.
is already written.
Mm-hmm. That's what CAD is.
I get you.
So that code's already been done.
So you just got to enter.
Yeah, you're not writing code. You're designing it.
Mm-hmm. You don't need any computer language. I mean, a little bit. I'm sure I haven't used the thing, but it's not.
The further this goes, the more of that stuff will be built in.
Mm-hmm.
So you think about something like the iPod. I think that's the beauty of Apple's products is like they aren't inherently better, but they're easier. Yeah. They do a lot more for you just behind the scenes.
Yeah.
So it's something needs to be updated, click OK. Okay. You click it. Whereas a system that, sure, like you're giving up control, but for most people, I think that's okay.
Yeah.
So this is like, oh yeah, you want to design your own measuring cup? Okay, here's some like drawing tools. All that code is in the background.
Guidelines.
Yeah, so it's like,
place for sure.
yeah, so here's some moron that is printing and reprinting measuring cups over and over again every time they're making a cake.
Wow.
It's just going to know that code.
Yeah.
And think about if we can get ourselves to a point in which we can recycle the material that we use to make things.
That is important.
How much better that'll be for the environment.
Yeah.
And then I also mentioned just briefly not driving to and from a store.
Yeah.
And also, bigger than that, not having those products delivered from a warehouse to the store.
From
God
who
knows where.
knows where.
Yeah. And then delivered to that distribution warehouse from the place where it was made. I mean, there's like an enormous amount of things to be saved.
It's a big shift. And
this idea is called decentralization, not having this hub of manufacturing where it gets spread across the globe. You want it here, it'll be made here by material that you have, and you can replace that material.
Close to where it's actually being made. This is also going to undercut the idea of the economies of scale. So like if you're going to sell a product that costs X amount of dollars to make one product, and you're selling it at Y, there's some point where it's like, if you're going to make one, you might as well make 50. You know, if you're going to make 50, you might as well make 500. If you're going to make 5, so the idea of like buying in bulk,
right,
that disappears. So the idea is that the price of making one with this one 3D printer with materials on hand, on site, where it will be used, and the only cost is digitally sending the design over the internet. It's the same price as making, 5,000 to make one
per unit.
And the measuring cup is another wonderful example of that exact process. Because how many times have you gone to a store and seen measuring cups and you don't need one? Nobody ever needs one. Everybody already has one. You don't need a measuring cup.
I need one with a handle.
Well, you do now. And when you do, they're there. And there's billions of them.
Yeah.
Right? So we're just making these things because they're going to be bought. And then they're going to just get thrown away. And they're going to end up in the ocean.
Yeah.
But now you could just make them at home to order for yourself when you need it.
And then melt them down and not have them sitting in your drawer without a handle.
And that's like an absolutely excellent case of how it's going to impact the world positively that you just don't even consider.
Right.
What happens when nobody needs to make all those measuring cups anymore? There will no longer be an enormous factory making measuring cups. And you don't think about that. Like, who thinks about
a giant factory making measuring cups?
There's
all the time.
So many of them.
I'm thinking I really want to like get a 3D printer, get good,
early adopt it,
and then go into work and be like, "Hey, prototype department, you're out of here."
Yeah.
No,
well, that's the scary thing. Is those guys are totally worth their money, but not for long.
Those guys are
for the machines that they're using.
No,
Yeah.
those guys even now are underpaid. I mean, they're probably getting top dollar for the company, like overall. But like, you look at what they do, what they're capable of doing. if I told either of you, like gun to your head, you need to make one of the parts that they're making with the machines they're making it,
we're dead.
And tell you what, I'll give you 6 months to figure it out.
That's
Wouldn't
a long
be good
time
enough.
to follow me around with a gun.
Yeah. You're quick, but not as quick
Do
as
I get
Bullet.
lunch breaks?
Shut up and get to work. But what I'm saying is like what these guys are able to do. You look at like something like this technology, and this is going to be more precise than what he's doing.
And so much faster.
So much faster. And
somebody who doesn't even know what the hell they're doing will be able to take a look at it and go, yeah, that'll work.
Like literally like hitting download and then print. That's how easy.
And the biggest change between the prototype and the production model will be the materials used.
Right.
Yeah.
So all you have to do is take that same CAD and go, oh yeah, that worked. Let's put metal in here, and this will be wood, theoretically, and plastic here for these joints and the ball bearings, and then it'll just go, and there it is. There's this thing. There's a yo-yo.
There are already 3D printers that can print in multiple mediums at the same time. So you could do
that is what is just
not at home yet.
Not at home.
It's there.
Yeah, but there are some at home that can do like, all right, so it's the same type of material, but it's like different colors.
Yeah.
You know what I mean? So it's like it's same type of plastic, but they can layer different colors in there.
Right.
And that's just the first step.
I went to a lecture at Reed about 3D printing.
Oh yeah.
And it was a little over my head. It was mostly about why you would choose the polymers that you would choose for their specific properties. And that was really fascinating, but it's way too much for me to bring back here because I'm not a chemist. It's just so much detail is going into what will be an automatic and easy choice for us in the future that it's astounding. But they had models of things that they had 3D printed, 6 or 7 really cool, incredibly intricate designs, and all produced in minutes, all just like really cool geometric shapes that interlocked with each other. And they were all just examples of how complex you could make an object. They weren't anything. They were just, one was a giant ball made out of cogs, so that when you moved a cog, all of the cogs moved, right? And it was just 3D printed. This incredibly intricate, awesomely precise ball of movable parts. And it was so cool to sit there and play with that and know that this was just design. It took nobody's hand other than the graphic designer to make sure that it was all mathematically correct. And then layer by layer, it was just extruded out of a tube.
Right.
And then hardened. And here it was in my hand. And it was no different than how difficult that would have been to make.
I think the incredible thing
like
is
a toy.
You could print that thing, the exact same thing
at home.
At home, yeah.
It's crazy.
Yeah.
Did you come across RepRap?
Yeah. That's the movement for home use, right?
Yeah. And also it's like the kind of the Skynet tie-in here.
I figured we had to get there at some point.
All right, so let's just like, this is an overview walking down like a timeline here. 2005, RepRap, the blog, is started. RepRap is kind of a shorthand for replicating rapid prototype or prototyper. I would say it's kind of like a enthusiast community, you know, like blogs and that kind of thing. What it has done, though, is in 2005, the blog is started. By 2006, the RepRap 0.2 prototype successfully prints the first part of itself. So these guys have made this 3D printer, which then printed a replacement part for itself. Okay.
Wow.
I'm going to skip ahead here to 2008. Someone uses a RepRap printer to print a RepRap printer. So, I mean, I don't really have much more to say about this timeline because from that point on, it's just like people printing printers for people.
Here's the ridiculous thought. What happens when AI gets a hold of this technology?
It's unreal. Now, here's the thing too. The RepRap printer can print a set size thing, okay? It could also print smaller parts of a bigger thing. So RepRap 2.0 could print RepRap 3.0, but RepRap 3.0 could have the capacity to print something 4 times the size of RepRap 3.0. And then you have RepRap 4.0, which could then print something that is capable of printing something 4 times the size of RepRap 3.0. So it's just like it's exponentially going to get bigger and bigger and bigger until you have RepRaps printing Toyota Priuses left, right, and center.
And then we're out of oil. There's no more plastic.
No more. Let's see here. In early January 2016, RepRap Pro, the commercial arm of the RepRap project in the UK, announced on their website that they are to cease trading on 15th of January. The reason given was congestion of the market for low-cost 3D printers. And basically, supply and demand. People are just clamoring to get these things.
Yeah. Everything that I've read so far has led me to believe that we're really on the brink of this being a everyday natural use technology.
Yeah. Seems like it.
We're right there. And it hasn't gotten into the home yet the same way that personal computers weren't in the home in 1991.
Right.
But 10 years later, 15 years later, it's in our pocket.
Yeah.
There's a lot fewer people that don't have a computer.
Yeah, it really does feel like right now, but I think also because of just the way technology grows, it's like going from the first BlackBerry jumping 1 year later to the iPhone.
Yeah.
That in our time took late 90s to 2007.
Like Palm Pilot.
Palm Pilot would have been a better example. Yeah.
Late 90s. Yeah.
Right. Late 90s. I think
I still remember I was in Hawaii visiting a friend of mine who was an early adopter of the Palm Pilot. And I still had like a flip phone.
Yeah.
It was just used to make calls. There was text, but nobody ever used it because it took forever and it was just annoying. There was like no good place to store it either. It was just like, like the screen was awful. He just made calls on it. It was just like, now I have a phone in my pocket. And this guy was so excited about the Palm Pilot. And he was like, there's the internet on it. And I was like, well, the internet sucks right now. Like, there's
can't do anything.
Hey, the internet's just newspapers.
Yeah, it's just words.
What
am I, an accountant?
Well, it's like, what is it? You're using AIM on it? Why don't you just text? Like, it still sucks. It's like it has a stylus. You can like have like your calendar in there. You can have all. I was like, that all sucks. Like, why do you care?
I don't even care.
And I'm looking back at that going like, holy shit, he got it.
Yeah.
He got
genius.
it. Yeah. Didn't make any difference. You know, he's still stuck back there with the Palm Pilot. No, he's doing fine. But he's
still on a Palm Pilot.
It's crazy to think like he saw that before anybody else. And that's what these home early adopters are seeing. Oh, yeah, well, I don't really need any of this stuff right now. Why would I want to produce and very expensive to get the polymers at home? And why would I be making any of this stuff? But they're doing it for fun. And then when it becomes mainstream and easy to do, they're going to be so far ahead. They're going to be the ones making the money. They're going to be the .comers.
And here's the thing too. I mean, predicting the future, I think is a fool's errand, but I don't see any way that another technology comes around in the next 5 years that replaces this one.
Right.
I see a huge defense by pretty much all manufacturing companies. All the big ones are going to say this is not the way we want to go, and have all the money to say that, and then not much longer after that having no money at all.
Well, there's a lot of things you can 3D print, and a lot of things will be separated from the mass production, but there's some things you just can't shoot out of a printer.
That's the thing, is I think like... So,
first thing that comes to mind is like a battery. I don't think you can just print a battery.
You could.
Are you sure?
You could.
It seems like there's some very specific materials.
Yeah, but it depends on like the materials that you're using to print, and then how refined the printer is. But I think down the line, if that's what that printer is set up to do, it's going to print it. Not today. It's like not an immediate thing. I think about like where I work. There's no printer right now that's going to make a part that we would ever sell.
Right.
I think that, and even like the prototype thing that I was talking about, it's probably not that much better for us, just like the scale that we're at. Like it's like a company of like Toyota that's going to make millions of cars with thousands of parts each. They're probably going to prototype this stuff. So I think it would be kind of a slower process for like the manufacturing side anyway.
Well, I'm curious what would happen to your company if the product that they made, although made with a different material and maybe not quite as high end, was mass produced for incredibly cheap. The people that would remain purchasing your company's product would want that product specifically, but there would be this huge loss in the market of that product.
I think that the only way that would actually happen would be people printing our products at home on their own printer. And then I think that would be so far down. Like we would be, the products we make they are really high end and fairly like a niche market. And
I feel like you're pretty safe.
Yeah, I would like to think so. We'll be around after the measuring cup companies go under.
Yeah,
for sure.
Yeah, well, the first to go are anybody who makes anything with plastic.
If you're making anything with plastic, you're done.
All other materials are going to take some time, but once it's there,
right.
The other big spot that we haven't touched on is healthcare.
Yeah.
There's just last year was a full jaw was replaced by a 3D printed jaw.
Yep.
Hips have been replaced with 3D printed hips.
Wow.
Yeah, and think about those all have production manufacturing places. People that make all of that material, they don't have to do that anymore.
Here's the thing too. So looking at like making something like that, like someone's hip, it's so particular per person. To get someone like those prototype guys that I work with, to get someone of that level to like hand make something like that, you have to pay these guys.
Yeah.
A lot of money. I mean, there's no other way to do it until you have a 3D printer.
Well,
Well,
think about the difference that'll be when you break your leg and you go and you have surgery on it and you get a plate put into your leg. And that plate gets 3D printed and so do the screws. But on top of that, so does the instruments used to perform the surgery, and so does the boot that they put on it has a splint. And all of that stuff gets made locally.
And it gets melted back down.
And gets recycled. It'll save tons of money. Make healthcare so much cheaper. Save the environment. And these are just tiny applications too. Like the real changes, the real fundamental changes, we won't see coming.
Yeah.
Like the real applications, what will be the everyday savior of this technology, the stuff that we look back on and say, how did we live without this?
Yeah.
We won't see coming.
Right. Yeah.
And I think though that's kind of what I was saying too, is that I don't see anything replacing this technology in the foreseeable future. Sure. And you know what? You can send me this soundbite in 10 years and tell me what the fuck.
You never saw it coming.
But at this moment in time, I think that this is
big stuff.
It just makes sense. It makes so much sense for so many products.
Yeah.
And the specialized stuff that we use every day is probably going to be okay. But like when you go to like a grocery store to buy the measuring cup, do you care what brand it is or like?
No.
What do you look at? Price?
Sure. Maybe some people would rather have a metal version rather than plastic. But
all right, so if you can print metal and plastic at home,
switch it out.
Is it going to?
Nope.
And then just recycle it immediately and.
I think you could design it yourself, or you could go on to a website that'll be very similar, I'm sure, to Etsy.
Already have a design that you like.
These are people's homemade designs. I like this one. I'll just take that.
Yep.
Of course, no one cares about the measuring cup design, but that application is so much bigger than that.
Yeah.
Now mix that with Siri or whatever voice activated technology.
Yeah.
You
Siri.
just have a thing. I need a measuring
Siri,
cup.
I need a
All right,
measuring cup.
no. This is what you'll say. This is what you say. Siri, find me a measuring cup that I would like based on my previous internet searches.
It's like I said in the beginning, there's such a really in-depth level of this that is beyond our ability to describe. The real engineering and the reality of
The
3D
people
printing
making a printer that can do this kind of stuff has some serious
I was
brains.
much more interested in the future prospects of it.
Yeah.
Really cool applications.
Yeah.
It's just the beginning.
And fundamentally, it's a really simple process. But after you get past the basics, it's very complex, very in-depth. Yeah. And for some of you out there, it might be fun to learn. But for the rest of us, is pretty much just like let other people figure that out.
Yeah.
Yeah. So if you want to learn more,
as always, look elsewhere.
Yeah. Why don't you go to Stuff You Should Know, huh?
Yeah, they do a good program over there.
Have they done an episode on 3D? If they have, it's been a while back.
They're partners. They're partners with the website How Stuff Works.
Yes,
which is where we do a lot of our research.
Is it?
That's where I do a lot of mine.
Really?
I don't know about you. Yeah. So certainly.
I've never heard of it.
Really? You've never gone to howstuffworks.com?
Really?
Really? Well, you should.
Because that's all they're doing is looking at How Stuff Works articles and talking about them.
Because they're involved in writing them.
Right. Most of the time they did write them. What I'm saying is often we will talk about something that's similar, but we usually go more in depth than they do.
That's surprising.
Do we?
Because we talk for longer.
I don't know if that necessarily means we go more in depth. I think we just kind of dance around the idea.
I think that we do. They talked about blood types. We talked about blood all over the place.
But did they talk about blood types more in depthly than we did?
I don't think they did, really.
Because I feel like we just kind of barely grasp a subject, hang on for an hour and a half, drink a bunch, and then
I would like to bring this up now, that the review that we got, the negative one.
Yeah, I didn't like it.
I did. And the reason is they were spot on. They were right.
There was like one episode that they were referring to.
Sometimes
hang on.
Yeah.
We got a review.
No, we have 3 or 4.
Yeah.
But
and one was negative?
One of them was like, I think that, what was the title?
It's all they do. Yeah. All they do is they watch a documentary and talk about it. Or some shit. And
let's read it.
Who said this?
Let me bring it up.
I don't know. Angelface64.
Somebody who clearly listened to 1, maybe 2 episodes.
It's incredible how little I care. But yeah.
It's incredible.
Review.
It's astounding. Let's hear the review.
Okay, so this is the most recent review out of 3 from Will the Beast. Will with 2 L's. So Will
I got Angel Face wrong,
Beast,
didn't I?
66.
I was pretty close to 64.
2 out of 5 stars.
What?
The title is Hack.
What do you have to do to get 1 star?
I don't know. The review
Hacks
is
get 2 out of 5.
The review is all they do is watch documentaries and regurgitate facts and anecdotes. Is that all we do?
Here's the response.
Wait, was that the entire
That's
review?
the whole thing.
Yeah. Here's the response.
All right.
That's pretty much the premise of the show. We just do
in various
surface
ways.
knowledge. That the fundamentals. We are getting you interested in the subject. So we will just do a little bit of research, regurgitate the facts to you, have a discussion on them.
Whether it's a documentary or an article that you read or some kind of internet video that you watch. But we put it through the prisms of us.
Like did you get mad when you watched Seinfeld and it wasn't a serious show? Were you like, these people are hacks. There's absolutely no riveting drama here.
Right.
All they do is they sit in an apartment.
I guess I don't know what he was expecting.
I guess we're not really clear about the purpose of the show.
We also say he, but I
think Will the Beast is definitely
Will the Beast.
It's Will
the Beast.
Yeah, Will,
and he's the Beast. I'm guessing that he listened to Orson Welles.
Oh yeah,
or something.
How much information do you want about Orson Welles? I mean, watch a fucking movie.
But that's the thing. We gave a bunch of information, more than I expected. I'm always impressed by how much I actually learn beyond what I expected you to bring.
Here's what I think is the best part about our podcast. This kind of external, internal discussion.
Yeah, it's us.
Is part of the show.
Absolutely.
There's no reason for the audience to still be listening. If you are, that's great.
It's great.
Yeah. Thanks for sticking with us, because this is internal, and you're getting a glimpse at what it's really like. You might get this on your Mark Marons, but you don't get this on your...
You don't get this on your Radio Labs.
No, you don't get this on your Radio Labs. You don't get this on your This American Lives.
Knows.
Hmm?
Think
you know what they do?
You guys...
They're professional. And I hate that. They have a team. They have sponsors.
I'm thinking,
where are you at?
What do you got?
We're getting away from the fact that Will to be 66 and go fuck themselves.
Yeah.
Yeah, you're stinking it up. What would be great is if Will, the Beast, is still listening. That'd be great.
You're a hack.
Yeah, you know what?
You're a talentless fuck. I'm using curse words.
Damn, Darren.
Yeah.
Sorry.
This is why we had to put explicit.
This is
on our
not
episodes.
Why.
This is exactly why.
This is
why
not
we're not
it.
going to be on NPR.
Carl Tanzler was
That was
taking
explicit
care of
on
that.
its own, sure, but we also use the curse words.
Listen,
I don't care.
Hey, we do what we want. It's free market.
Would I change anything? No.
I love this.
I'd have an office with
a space
with a view of the skyline.
Sure,
and I'd have a secretary and probably a team of interns. These are things that I would change.
Do my research
the
for me.
content of the show itself, absolutely not.
I'm still going to watch a documentary every now and then.
Yeah, why not? And I'll tell you about it. That's the point of the show.
That you tell me about it.
Yeah, I'll tell you.
And you're the audience.
Exactly.
Sitting in.
The audience by
asking
proxy.
questions. Yeah.
Guys, if you didn't know what the show was, this is it. We just laid it out for you.
Honestly, I'm not that upset. I don't care.
Who cares?
I really don't care.
We still have people that like what we do.
And
we're only going to get more.
Okay, I'm saying right now, as of the recording of this episode, they haven't released anything about 3D printing.
That's as far as
we
they
know.
did on
shit.
April 1st of 2014. I mean,
really?
Yeah.
3D printing. That's the name of the episode. How 3D printing works.
How 3D printing works.
Son of a bitch.
Well,
let it be known that we did not know that.
Yeah, that doesn't matter. Willoughby 66 is going to tear us apart.
He's going to be all over us.
Also, it doesn't...
Like a fly on shit.
I haven't heard that episode as of now. I'm going to go out on a limb and say ours is better.
Why don't you just listen to them both? Listen to ours, listen to that one. It's
Get
fun.
their perspective. Get ours.
Mm-hmm.
Yep. Life is short. I think that the real foundation of the fundamentals is you can't spell fundamentals without fun men.
Right?
Mm-hmm.
That's
us.
Yeah, if anybody's still listening, then they really...
They get it.
They get it. They get us.
They really get it.
And
we do need to wrap
you.
it up, though.
This has been a great time, guys. I'm Martin Wallace.
I'm Darren McCarthy.
And I'm Dan Fury. Thank you for listening to Stuff You Should Know.